All right, well, welcome back. Hope you're doing well. How's your cryptography program coming along? You feeling okay on that? Good. So it's now we're taking a look at how we do object-oriented programming. Now, we've been mentioning this from the beginning of Java because in Java you can't write code that isn't object-oriented. In some languages like C++ and Python, you can either write your code in a procedural mechanism or using object-oriented. Well, Java doesn't really allow you to do anything but object-oriented, which is interesting because here we are in week 8 and we're just explaining how objects work. Well, that's probably one of the kind of weirdest things about Java. Once you understand object-oriented, it's a beautiful thing, but Java really pretty much insists that you use object-oriented from the beginning. And getting around that has given us some of the weird things we've been doing in code. So hopefully today you'll kind of get a chance to understand how all of this stuff really works together. And so we're going to begin by looking at this program, Circ Demo. We're going to take a look at some objects. Well, what's an object? Well, you know, we already know this kind of in real life, right? An object here is an object. It is a coffee cup object, right? And what do you know about a coffee cup? Well, does it have any characteristics?
It's usually made out of porcelain.
What's that?
It's usually made out of porcelain.
It could be made out of porcelain, so we could have material. Now, maybe I have a plastic one or something, right? Does it have a color?
That one's white.
It's white. Now, you can't really see it, but it has a fullness in there. There's coffee in there. It's good Nicaraguan coffee, by the way. All right. So it has all of these characteristics. There's things that a coffee cup has. We call those properties or attributes. I mean, think about a cow. Would a cow be an object too?
Yeah.
Yeah, sure. Does it have any properties?
Yeah.
Like what? So it might have properties like breed. You know, is it a Guernsey cow or is it a Longhorn or something? It might have properties like color, right? It might have a property like age, I suppose. You know, how old is the cow? Maybe it has a mass. How much does it weigh? So those are properties. They're a lot like variables. They're properties of an object. So an object could be a thing with properties. But also, an object has something else. An object can do something. Cow object's more interesting here. What sorts of things could a cow do?
Eat.
It can eat. That's not the most interesting thing it does, but it's pretty interesting. It just... What else can it do? Oh, it can move. That's one of my favorite things, right? Cows can eat, they can move, they can give milk. So those are methods. So an object has attributes or properties, those are things about it, and it has methods, those are things that it can do. Well, it turns out that using this same idea gives us an ability to think about certain kinds of problems in some very, very powerful ways. So we're going to take a look at a really simple object, a circle, and see if we can understand a lot about what's happening with this circle by putting it through its paces, by looking at some things we can do with a circle if we thought of it as an object. So when you look at this code, you'll see that it's a little bit different than code we've written before. We still have this main, but up until now, pretty much the main has always simply called the name of the class. So new circ demo 1 it would have. But this one is a little different. For the first time, I have two class definitions inside the same file. Now, they can be in separate files if you want, but just to make it easier to manage, I put both of these in one file. In Java, if you can only have one public class inside a file, but you can have as many classes in there as you want, just only one public, and that's the one that would need to have a main if one does. All right, so Circ demo is my main class. That's the one that's going to run. But look what it does. It creates an instance of circle 1. Well, what's circle 1? Well, that's a new thing we're about to make. And so we basically have a new variable type called circle 1. And we're going to make one of those things called myCirc. It's a new circle 1. What? Okay, don't worry. It's okay. We'll explain all of this. But essentially, I've created a new variable type. Oh, okay, and I'm going to call it myCirc, and it's going to be a new circle 1, and it will be my circle 1. Take a look at circle 1. It couldn't be much simpler. So class, you've seen that keyword before, and circle 1, that means, okay, that's the name of the class. And then it has right now just one thing inside it. It looks just like a variable, right? But a variable defined in the context of a class, poof, magically, that becomes a property. So we have a circle 1 class, and it has a property, which is a float called radius. So a property is just like a variable. It's just when we define it inside a class, we can call it a property. So have all the variables we've been making so far been properties? Yeah, pretty much. But it's okay. It's okay if you didn't think of it that way. This is not a very bright object. It doesn't do a ton, but what it does is interesting. It contains a radius. Now the thing is, this thing here is a definition. Anybody like to cook? Yeah, I love cookies. In fact, my daughter, when she was there, was famous for her cookies. Everybody liked her because of her cookies. Because she makes good cookies. And you write a recipe, right? You need milk and eggs and flour and chocolate chips and so on. And you take that recipe, right, and then you eat it. Would that be a good idea? No, we don't eat the recipe. What do you do with the recipe?
Cook it.
You follow the directions, and then when you follow the directions, you get a cookie. Or a lot of cookies, we hope, right? And so this part is the recipe. And then when we follow the instructions for the recipe, we can get what's called an instance. So in object-oriented, sometimes we talk about a class, that's the recipe, and the instance of the class, that's the cookie. And so the class is coffee cup, but this is an instance of the coffee cup. I guess we're making instance coffee. So do you understand the relationship between a class and an instance? So this is the class, circle 1, and here's a new variable of that type called myCirc. Now, once I have created this thing, I can refer to its properties with this little dot syntax. So myCirc.radius. That's a floating value, so I can assign it a float. Remember, this little f just means, hey, that's float. So we're saying, hey, your radius is 1.0 float. So could I refer to radius just by itself? No, because this is a property of the circle 1 class, and myCirc is a circle 1. So we can add stuff to it. We can also refer to it. System out println myCirc.radius. Well, let's run this. It's not super exciting, but let's run this. What do you think it should do? All right, we compiled it. We're running it. 1.0. So all it prints out is a 1.0, but that's what we wanted it to do. Right, there are much easier ways to get a 1.0 on the screen. But this is the beginning of understanding how objects work. Are we good? Can we move forward? Outstanding. Okay. So now let's make it more interesting. See, part of the point of having properties is that when we create something, we want to know we can count on its values. So if you have a cow, it has a color, right? It has a mass. It has these things. When I create a coffee cup, it has a color. It has a material. It has how much full is it. It could be empty, but that's still a value. And so when we create an instance of a class, we want to know that all of its properties have some sort of predictable starting value. Now that value could be 0, it could be a null value of some sort, but there will be a value and it will be predictable. And so now I'm making a different class called Circle2. And so Circle2 starts out almost the same. We have its property, radius. That makes sense. And then you look in here, and I have put a function inside this thing. Oh, that's interesting. And we've done this before, really. I didn't really explain exactly what was happening, but we've done this before. This function has the same name as the class. Now, what's special about that is it's called a constructor. And a constructor is a function with the same name, or it's a method with the same name as the class, and it is automatically called when this thing is being born. So as soon as a cow is born, it has coloring, it has a weight, it has, you know, all the things a cow has. That's what the constructor does, is it gives us those things. So what's interesting is that every other method in Java requires not only the method name but a return value. Well, Circle2, the method name is also the return value. So this is how we get a circle. This creates a Circle2. So when I say new Circle2, it's going to actually call this function. A couple of really nice things about that. One is this: we can define it so that it takes a parameter, so that you're not allowed to try and create a circle without passing it a floating value. Well, that's nice, because now I can guarantee that my circle is going to have a radius. And so this is just a parameter. It's just a function, but because the function is the same name as the class and it's defined inside the class, this magically becomes a constructor. And so we have this float called local rad or local radius or whatever. That's just a parameter. So when I call new Circle2 with 3.1f, well, it just passes that over to local rad. Local rad gets copied to radius. And then that's the end of the constructor. So take a look at this code here. I make a Circle2 called myCirc, and I pass it this value, new Circle2 3.1 float. Print out its radius, it's going to be 3.1. Change the radius, print it out, it's going to be something else. Let's run this and see if it does what we think. And we'll try some experiments. It prints out a 3.1 as we expected and a 4.5. Well, let's do something different. What if we do this? 7f. Okay, can we do that? Sure we can. Save it, compile it. This time we're expecting to see a 7 in the first try. 7, son of a gun, it's working. So this is pretty exciting. We can make a circle with any size. Now, there's some other things that we'll sometimes do here. I don't always like calling this local rad. See if I've done some other. Okay, we'll come back to that idea. Okay, so everybody okay with this one? We good? Good, all right. Because it just keeps getting slightly more complicated. All right, now, here is another example, which is interesting because sometimes I'll know how big I want my circle to be. Sometimes, though, I'm going to want it to be a floating point value, but what if I'm lazy? You know, Java's really particular about things, and if it's a float, darn it, we need to make it a float. But what if you just want to say 7? You don't want to say 7f. Or what about this? What if you can't make a decision about what the radius should be? Maybe you want to be able to make it without a radius at all. It should still do something, right? If you take a look at how this circle is being used, I have made the circle much more powerful because now I can create it with a float, or I can create it with an integer, or I can create it with no parameter at all. Well, that's kind of neat. And that does exactly what I want it to do, and we'll see how we get there. Regardless of what kind of data I put in there, a float or an int or nothing at all, it will still create a circle with a legitimate radius. Let's run it, make sure it's really doing what we thought. And yeah, all these seem to work just fine. Okay, super. In fact, what it does is if we pass it a 5.6 float, the radius is 5.6. If we pass it the integer 5, it quietly converts that to a float and says, oh, your radius is 5. And if I don't pass it anything at all, it just says, well, okay, I'll make it a 10. That sounds good to me. So we have made this thing quite a bit more sophisticated. Actually, I'm going to change this line because it's not as complicated as it once was. Hold on, this line has gotten a lot nicer, so I'm going to fix it so it works better. My circ.radius. Let me just make sure this is still working correctly, but I think it is. Okay, so I'll explain what that line is doing. It's a little interesting, but don't worry about it right now. I just simplified it. So let's take a look at what circle 3 is. So I still have this single property radius, but now I have 3 different constructors. And this is called overloading. It means we can have more than one function with the same name as long as they have different parameters. And the reason we really like this is because, well, it gives us more flexibility for the person who's using this object. So I can pass it a float, I can pass it an int, I can pass it nothing at all, and it will know what to do in each of these cases. So if we pass it a float, well, then it simply says, no problem, I can copy that over to the radius. If I pass it an int, it says, fine, convert it to a float, and then I'll pass it to the radius. If I don't pass it anything, it just assigns the radius 10 float. So regardless, it's going to give us a radius that's a floating point value we can work with. And so that's called an overloaded constructor. And what that gives us is a really important idea in object-oriented called polymorphism. And that is an object kind of knows what to do in different circumstances. And that's a really, really powerful mechanism, because as we start writing more and more sophisticated programs, we're going to run across these situations where an object kind of needs to know what to do in different circumstances. So given that, now you can see how this code works, and then I'll finally explain what this little printf does. We can print out the radius, we can print out the integer. Now this one, if you look at it, it printed out as 10.00. Well, what that's doing is it says, well, it's a floating point. Sometimes those get really messy and they have a lot of extraneous values at the end. But there's a special thing called printf, which allows you to do formatted printing, and it's just kind of fun. No parameter, and this symbol here, percent, means I'm about to do a special string. And the F means floating point value. 0.2 means show me only 2 decimals. So you can look up the printf command if you want to do some more sophisticated printing. You can do really neat stuff like specify how wide each field is and convert things to different types and so on. So it's a handy little tool. It used to be much more complicated in Java than it is now. So I didn't used to use it in Java. Now I like it because it's easier than it used to be. So you can look that up if you want more information, but you don't ever have to use it. The print line is fine. Okay, we okay with the circle 3? All right, let's move along. All right, now this one is a little bit interesting because if you look at this, my circle gets circle 4. I didn't give it a radius at all. But now, you know, up to now, I could just say my circ.radius gets some value. Okay, that's true. But this time I did it differently. I said my circ.setRadius 7.3. So now I have somehow created a new method which allows me to set the radius to some value. And again, I seem to be able to do that with an integer as well. Now, set radius, I can't do that with blank, where I decided not to, because if I don't know what radius it is, why would I call set radius? Now, this may not seem to be necessary yet, and it actually generally wouldn't be. But it does turn out to be real handy, as you'll see in just a minute. So here's my function. Now the circle is getting more complicated, that's true, but most of this is stuff you've seen. There's my circle 4 with a float. Here's my circle 4 constructor with an int. Here's my circle 4 with nothing. Now here's my set radius, which looks very much like one of the constructors. And there's another set radius. These things work very similarly to the constructors, but they are functions, methods that allow me to set the radius. Well, why do I need that? I could already set the radius. Well, the thing is, if I just tried to do this, so let's say I've got a circle. And okay, and I said my circ radius gets 3.7. Well, no, 3.7f. Well, that would work, right? Because the radius is a float, and as a programmer, I was very careful, and I assigned it a float. That would be fine. The thing is, what if I'm lazy? If I just said 3.7, Java will probably assign that as a double, and it'll crash. Or if I just say 3, Java will certainly think of that as an int, and the program will crash. So I was so careful with my constructor to make sure that regardless of what kind of data I sent, it would be legit. It would actually work. It seems like I should have the same kind of safeguards in place for assigning a radius. So rather than assigning a value directly to a property, it may be better to use functions, because then we can have that kind of protection around them. In fact, it's not only a good idea, it becomes essentially the law. Is that we're not going to allow the user anymore to directly change a property. We're going to force them to go through some sort of a method. And why would we do that? Well, because we want to protect the data and make sure that it always has a value that's legitimate. And it could be legitimate in a lot of ways. One thing you might do is simply say, okay, well, I want to make sure it's a float. But you also might want to say, well, a circle shouldn't have a negative radius. And so we could write a function that checks and makes sure that the radius that we're passing is, in fact, positive. Maybe you don't want a radius larger than 1,000 for some reason. You could also put that filter in place. So we like to protect our data by only allowing the user to change things through our own methods. And that would be a pretty powerful thing. Now, right now, we can change it through the methods, but we don't have to. So this is called a setter. So a setter allows us to set a property. And typically when you create a class, you'll create its properties, and then you might make setters for each of those properties. Everybody following? Okay, so now let's take a look at the next example. It's related. Now this next example is almost the same. It still allows us to create a circle, and we still can set the radius, but now we can also get the radius. So when we have a radius property, we might have one or more set radius methods, And we might have one or more get radius methods. That allows us to get the thing. And so if you look at it in use, now I could say, getting the radius, myCirc.getRadius. Now again, we don't have to. We could still say myCirc.radius. That would be legal. But it's not what we prefer. We prefer to use a method to get the value. And so when you look at Circle 5 now, it has for radius one or more setters, and in this case, two getters, one that gets the float and one that gets a string. You might want that. So a set method pretty much always looks the same. It's almost always called set and then the name of the property. And then it always takes a parameter because you don't have a setter unless you have some value you want to set. And then it copies that parameter over to the radius or to whatever the property is. So setters always look like that. The setters are pretty much always void. Occasionally you'll see a Boolean setter, but usually they're void. They don't return a value. A getter always returns the same type as the property. So if I have a float called getRadius, or if I have a property called getRadius, or I'm sorry, if I have a property called radius that's a float, I'm going to have a getRadius, which is also a float. And that turns out to be really, really useful with the next thing. So now when we look at the code happening, I can set the radius and I can get the radius. And this turns out to be really, really useful. Let's run it. Make sure it's doing what we think it's doing. And it's working just great. It's doing exactly what I wanted it to do. So it is allowing me now to use these methods to change and retrieve data. Okay, that's good, but I could still do it by hand. We'll come, actually I'm gonna skip ahead one, I think. Yeah, I'm gonna go ahead and skip ahead to this one because I think it fits what we were doing. Okay, so Circle 7 is very similar to the previous ones. And we can assign something to Circle, and we can get something out of Circle. Okay, that's good. Now, that's fine, but take a look at this. myCirc radius gets 5f. Let's try and compile that. I hope it breaks. Oh, let me do that. Let's do it that way. All right, I'm gonna see if that, oh, is that, okay, good. Good. Now that broke. Why wouldn't it let me change the radius? It's, well, now I cannot change the radius this way. I have to use a getter or a setter. Why is that? Well, because I told it so. Take a look at what my code does now. Radius is still a float, but now I have called it private. Well, you've seen these words public and private floating around. What does it mean? Well, just like it does in English. Public means anybody can mess with it. Private means that only, it's none of your business. You can't have this information. You can't mess with this. So I'm going to make my radius private, which means that only this class can have access to it, nobody else. Why is that useful? Well, now this forces people to use my getter and setter methods. And that's extremely handy. Now, if you want to get access to the radius, you have to use get radius. If you want to change the radius, you have to use set radius. Now, why would you want to make it that hard for users? Well, it turns out it's really very useful. Here's a classic example. I wrote a game engine, and in this game engine, I'm rotating objects. So I have all these things that are rotating and moving around, and I don't know if you've done any game programming yet, but the math is pretty difficult. We're doing all rotation is a bunch of trigonometry functions. And of course, the trig functions in most math actually work in radians, not in degrees. Now, I'm very comfortable with radians. I've done a lot of math. And definitely in my game engine, I want to do my work in radians. There's another problem that the rotations of radians are a little bit different. And radians, we measure from 0 to 2 pi radians around a circle. And 0 starts there and it increases this way, where most young people are used to measuring angles in degrees, which start out this way and they increase, in the other direction. So radians are what I really want to use, but my user doesn't understand radians. They're going to want to work in degrees. You understand the problem? So I have a situation here where I really want my angles to be measured in one thing, but I don't want my users to really work in that thing. I think they'll be confused. So I'm going to give the user the ability to set the angle of an object. So your dragon, you want to point at 45 degrees. Fine. You can think you're pointing at 45 degrees. What am I quietly doing? Converting that to pi over 4 radians. But here's the way that works. There is a set angle method in my object, and that takes in an angle measurement in degrees. But then what do I quietly do? Convert it to radians, store it locally in radians. And so I can do all the math exactly the way that I want. Then there's another method when the user wants to get the angle back. They get the angle back and they're expecting it to be in degrees, but it's not. So I quietly do the little conversion to convert the radians that I'm storing back to degrees, pass that back to the user. They never know that we aren't storing things the way they're putting them in. Another great thing I can do with this is it's impossible for them to set it to an illegal angle, because I can force their angles to be between 0 and 360, for example, and then when I convert it to radians, it's in a legit radian measurement. So a lot of times we'll do this. It's called data hiding, where we'll store the data internally in our object, and then the user only has access to it through the methods. They're called our access methods. So now you have to use getters and setters to get at this thing. And that may seem like a little more work, but what it does is it protects your data and makes sure that your data has integrity. And this is one of the biggest problems with commercial code, is that you want to write this complicated program. You want to make sure that the data is doing what it's supposed to do, or you could get really confused. Now, I had it listed as something besides private. I had it listed as protected. And to make another later example make sense, I'll change it back. But private means nobody can touch it but me. And public means everybody can have it. Of course, there's some similar things. Protected is a little bit different. I'll explain what that means in a minute. But everybody okay so far? All right, so that should still compile, that should still run just fine. All right, cool. All right, so now let's have a little more fun. Now let's talk about some other, let's go back to this. This is one I skipped. So Circ Demo 6. So Circ Demo 6 is interesting because, well, we make a circle 6, and then we print out its radius. No surprises there. But now take a look at line 11. Class circle 6 extends circle 5, whatever that means, but what is the code inside circle 6? Well, there isn't any. There's no code there. What's going on? Okay. All right, take a look at this thing here. We have a police Lamborghini. How would you make a police Lamborghini? Step 1, get a Lamborghini. Step 2, put the paint job on it, then the lights and all of that sort of stuff, right? So then you have a very fast cop car. But how do you make a police Lamborghini? Well, you start with a Lamborghini. Yeah? Well, and the nice thing about that is that you don't have to start with, well, let's make a wheel, and let's make another wheel, and let's make a body, and so on. A lot of times you don't build stuff from scratch. You build it from other things that are already pre-made, right? And so the police Lamborghini is a great example of that. This is, how do you make it? Well, you start with a Lamborghini. And then all you have to do is the things that change it to make it a police Lamborghini. It turns out the same thing is happening in our code here. Because what I'm doing is circle 6 extends circle 5. What am I doing here? Well, this is called inheritance. And it's one of the biggest ideas in programming. And what I'm saying is this. I'm going to make a new class called circle 6, and its mama class is circle 5. So I want you to get all of your best ideas from circle 5. Now, in this case, I do nothing else, which seems silly, I know. But I do nothing else except extend circle 5. But because circle 6 extends circle 5, it already knows how to do everything that a circle 5 could do. Does that make sense? So, can a police Lamborghini go really fast? Yeah. Why?
That's a Lamborghini.
Because it's based on Lamborghini, and Lamborghinis go really fast. Is a police Lamborghini cool looking?
Yeah.
Yes, because a Lamborghini is cool looking. Does that make sense? And we use the same idea in programming. We'll build simpler objects, and then we will sometimes extend them to make more complex, more powerful objects, but we'll get access to everything that the parent class already had. So if your daddy was a Lamborghini, then you're a Lamborghini. That make sense?
Yeah,
You're a Lamborghini because your daddy's a Lamborghini. Now, it doesn't work quite the same in biology. We tend to have two parents, and we get a random set of characteristics from each. We don't do that in programming. We definitely don't do that in Java. We have exactly one parent, but that parent could have a parent, could have a parent, could have a parent. And so we will see inheritance, but it doesn't work exactly the same way it does in biology. So this is interesting, but it's not that interesting. Let's jump ahead to number 8, where we see some very interesting things happening. Circle 7 did a lot of things, didn't it? But every time I try to add more to this, I'm copying and pasting. That's a bad idea, because I'll mess something up. But look at circle 8. What does circle 8 do?
Getting stuff in circle 7.
It does everything circle 7 does, and I'm going to add some new stuff. And so this is why inheritance is such a big deal. It allows us to improve on the previous model and to build more powerful things. So let's take a look at how this thing works, and we'll see that it's got some interesting behavior that could be really powerful for us. So here's one, for example. It has a get circumference method. Remember the circumference of a circle? What's that? That's how far around it is. You measure how far around it is. You put a measuring tape around your wheel. That's the circumference. Ooh, we can get the circumference. Now, this is very interesting because where is the circumference stored? That's actually a really good question, isn't it? Would we have a circumference property? Nope. No, we wouldn't want to. Why? Because would you want to allow the user to change the radius to 5 and the circumference to 1?
No.
No, because then we've just broke math, right? I mean, if the radius is 5, the circumference has got to be, well, 2 pi r, so 2 times pi times 5, so it's 10 pi, 31 something. Yeah? Okay. So this is a great place for data hiding, that we don't want to allow the user to change the circumference. We want them to be able to think there is a circumference, but is there really a circumference? Nope, only a radius, and we'll give them the circumference when we want to. So when we look at it being used, okay, we've got this get circumference. It's interesting. It's interesting in a couple of ways. This one is not too surprising. MyCirc.getCircumference. And then we also have this version that seems to be a little bit different. We can get the circumference of a circle whose radius is 1, even if we don't have a circle yet. That's interesting. Here's something else interesting. When we want to make a circle, we can just tell it, hey, make it large. That is potentially interesting. So there's a lot of interesting things going on here. Let's take a look at some of what's happening. So circle 8 extends circle 7. We're going to begin by having everything we had in circle 7. Now we're going to do some other interesting things. Private final float pi gets 3.14159, whatever. Okay, so what are we doing? Well, since we may be working with pi, I'm going to store it as a constant. Should pi be a variable?
No.
No, the whole definition of a variable is it changes. You're going around changing pi, you're going to make a lot of mathematicians mad. So we don't want to allow pi to change, so by setting it final, that turns it into a constant. Now, a lot of times you'll also see final used for constants like this. Public static final int large. Public static final int medium, small. So I'm having some other constants here, and these constants will just let me say small, medium, or large. Well, why don't I just use strings, small, medium, or large? Well, strings add a lot of other complexity. I'm worried about, do they spell it right? I'm worried about capitalization and so on. So I'm going to define sort of a pseudo variable called large. And it's going to have an integer value 2. I'm going to have another variable medium. It's going to have an integer value 1. A third value small. It's got an integer value of 0. But I don't really want these to change, so I'll make them final. Now, traditionally in programming, all caps means it's a constant. That way I can tell this is intended to be used as a constant, so it's not going to be changed during a run of the program. Okay, so why is that interesting? Well, it's going to turn out to have some really interesting behavior. First of all, public circle 8 float radius. Well, okay, we can give it a float. Now, I didn't have to do any constructors before, but now I am doing a constructor to show you something interesting. If I create a circle 8, what I wanted to do is do whatever the parent, circle 7, would do. So this super means call my parent class's constructor. Oh, and in any constructor, if you want to, you can begin it by calling the parent class constructor. If nothing else changes, you don't have to do this, but you can. This is called overriding. So if I have a method with the same name as the parent, then I've overridden it to get maybe some slightly different behavior. Well, we're going to definitely do that here with the integer constructor. Now, rather than the integer just be converting to a float, I want it to read one of these things. I want it to be able to read large or medium or small. And then if they said large, I'll set the radius to 10 float. If they said medium, I'll set the radius to 5 float. If they said anything else, I'll set the radius to 3 float. Why? It's just a different way of thinking about circles. I'm going to allow them to have different values. They can say now large, medium, and small. So that's pretty neat. You take a look at that here. When I said new circle, circle 8.large, I'm saying, okay, I want you to make a large circle. Why do I say circle 8.large? Well, because large doesn't have meaning by itself, but circle 8 large does. Okay. So now let's take a look at this function here, get circumference. Well, circumference is special, isn't it? Because we're not going to allow the user to set it. It shouldn't really be a property. It should just be a method. And so get circumference is neat because all it does is this. Return 2 times pi times the radius. Oh, you remember that? 2 pi r is the circumference of a radius, of a circle? So the user might think there's a circumference, but there really isn't. There really isn't. All there is a get circumference, which quietly calculates the circumference based on the radius. And that's exactly what we should have, because the circumference is dependent on the radius. If they change the radius, the circumference should automatically change. Could we have a set circumference? Well, sure, I suppose we could, but should we be setting the circumference? If we have a set circumference, then it would just set the radius. We would have to calculate what the radius would be, do a little algebra, and then we would tell it, sure, yeah, you can set the circumference, but what I'm really setting is the radius. Now, here's another interesting thing going on. This looks like almost the same function, doesn't it? Circumference. But this one is called static. And finally, I want to explain that static keyword that we've been seeing all along. Static, I wouldn't call it static. I would have called it class level if I was in charge. And because what this means is that something that's defined as static operates whether or not you have an instance of the class. So the static get circumference, we can run that. We can run this version before we have an instance. So you look here, we haven't made a circle 8 on line 5, yet we can still call circle 8 get circumference. When I make a method that's related to the class name, that method needs to be static. It needs to be class level. That means it can work even if I don't have an instance of the class. And so this form of get circumference is a static method. I don't have any properties here because I don't have any circle 8s. I'm just saying, hey, go to circle 8. It has a static method called get circumference. Now, because there is not necessarily a radius, I have to pass it a radius. So here is that static method, get circumference, pass it a radius. Now, in a static method, I cannot deal with any variables that aren't also static, which is why I did some magic to kind of move some of these things around, because we were having a lot of static keywords. So this version of the function is an instance version of the function. It works if I have a circle 8. This version of the function is a static or a class version that works whether I have an instance of the circle 8 or not. And why do we care? How does that fit with things we've done before? Well, take a look at this static method, public static void main. We've been typing that all semester. Now it's beginning to make a little more sense, right? The main method is the method we use to start everything up. And so when we're running main, we need it to be public or we can't do it. So that explains why it's public. Why does it need to be void? Well, main doesn't return a value, so that makes sense. Why is it static? Well, the whole point of a main method is usually to start the whole thing going. And so, because by definition, I don't have circle 8 yet, the main method has to be void. Has to be static. So main is always static because the main thing you do with it is create an instance. And that's why there were some kind of crazy rules around. Once I was in main, I couldn't use any variables that weren't static because it wouldn't know how to work with them. That's why normally in main all we did was call a constructor. Now we have an instance and we can work with it. So that's why the static. Now we still haven't really talked about this part. All that really it does is allows us to work with command line arguments, but we're not going to typically use those. So for now, you can just continue to think that's magic. Okay, so does circle 8 make some sense? Okay, one more. Okay, so the circle 9 is interesting because it talks a little bit about another interesting thing we do in Java. And it's an important thing to know when we're working with objects. The first question is, can we make an array of objects? And the answer is, well, we could make an array of everything else, right? Why not make an array of objects? Well, we can, but you have to be a little bit careful about it. So circle 8, all the circles, gets new circle 8 with 10 elements. That does, in fact, create a new thing. So the new keyword means I'm going to create a new element. But what is it creating? Is it creating 10 circle 8s? No. It is creating an array with enough room for 10 circle 8s. So the array, all the circles, has been created. But the circles inside the array have not. So when you create an array of elements in Java, you have to do it in 2 steps. So if we tried to print out this line here, all the circles sub 0, you'll just get a null. I mean, we'll run it and see. There's a null because at this moment here, all the circles sub 0 is null. If I try this line here, get circumference, it's null. There won't be one, and it'll crash. Let's save it, compile it, and try. Crash. Why did it crash? Because all the circles sub 0 is just null. It's not a circle yet. So when you create an array of objects, you also need to use a loop that initiates each element. So you need to explicitly call the constructors of each of the elements. So all the circles sub I gets new circle 8. It's a really easy step to forget. So you would think when I create an array of objects, I've created all the objects. No. You create an array of objects, you also need to explicitly run the constructor. If you come from, say, C++, you know a different behavior. This is a really important jump when you're going from C++ to Java, is that we need to actually initialize each of the sub-elements. And now, line 23 will work just fine. It will be able to give us the circumference. And let's see it work. And compile and run. So that's working just fine, and that is exactly what we'd expect it to be. With a radius of 5, I'm expecting the circumference to be 10 pi, and it is. Everybody good? One more thing to note here. Why is it that this program assumes that we have defined and compiled circle 7 and circle 8? Well, because I'm creating circle 8, and circle 8 was dependent on circle 7. And so you have to have all of these things in the same directory in order for it to be able to find them. So you want to be kind of careful about that. Everybody feeling okay so far? Okay, so let me talk about that cryptography assignment. How's that going? Everybody got it done?
The last one, or
yeah.
The last one, yeah. The high-low?
No, okay, so after the high-low, there's one more we're doing that I just announced last week. That's the cryptography. And so we need to be working on that. I'm going to give you a little more time to work on that if you need it. Now, I will not be online on Friday because I'm giving a talk at another university, but I will try to read my email. So if you have a question or you're lost, just drop me an email and I'll do what I can. And I'll let you have another week to work on this one because then we have another assignment coming up next week. Everybody good?
Yeah.
All right. You guys are amazing. Have a great day.
Can I talk to you on the release?
Sure, sure.
Is your computer okay?
Nope.
No, what happened?